This is a lab about constant velocity motion. In order to obtain constant velocity motion, we need to set the net force equal to 0, because Newton's second law shows that when there is a force applied to an object, the result is the acceleration of the mass. So we need to cancel between them the different forces present in the surroundings of the object. When net force in a movement is equal to 0, we see in Newton's second law that this part of the equation goes to 0. So as this part of the equation is cancelled, we can see that there is the same value of final velocity and initial velocity. And this tells the story of the object that moves, telling that it have a constant velocity motion. We can also know the final position of the object if we know the initial position, the constant velocity value times the change in time. We are going to analyze the movement of this red ball in a brief interval of time equal to 1.435 seconds. The axis is set at the left of the ball because it moves in the negative x-axis. We obtain this data from this ball that we are analyzing here in Tracker. We obtain data of initial position, the next position of the ball, and that displacement is set in a time of 0.33 seconds. With this data, we can obtain the magnitude of the velocity on the motion. We set those values in our. So we can see here the initial position of our vector, of our object. This is the velocity of the movement. We have a short delta t, and this is the total time of the movement, net force equal to 0. When we run the simulation, we can see that the movement is exactly the same that we saw in our video. When we introduce the obtained data in a spreadsheet and compare with the data obtained in Tracker, we can see a difference between the experiment measure and the model. The little difference between them is because the model calculates a linear motion. We see it in a red line with constant speed. In our experiment, trying to set in order to obtain a constant velocity motion, is pretty difficult to isolate the variables like the friction against the table, the gravity vector, and even the air resistance. We see the action and reaction of those variables in the object movement here, in the difference between them. If we change the axis orientation, we can see that there is a change in the sign of velocity, and we see the ball moves into the positive x-axis, and there is a difference in the graphic that moves now in the first quadrant, which is a positive displacement. How many pushes and pulls are added together to give 0 net force in the movement of an object? We can think that every push is an action and the pull the reaction, so what we need is to have exactly the same quantity of pushes and pulls in order to obtain a movement with constant velocity. If we want the object doesn't moves, the magnitude of the pushes and pulls must be exactly the same. So the magnitude of this vector must be exactly the magnitude of this vector, and we have a net force equal to 0. But if we want that this plane moves, for example, in front direction, what we need is to set this vector magnitude greater than this one. This magnitude is produced by the push of the engine, and this is the air resistance. So if in every moment of the movement we have the same magnitude here and the same magnitude here, we can obtain a constant velocity motion. Thank you.